Okay, so let's get started. My name is Margaret Li. I'm the lead program manager working on Tahoe Search. In addition to delivering great search capability in Tahoe so that the customer can better find their information, my group is also responsible for delivering search technology that is integrated with Exchange, SQL Server, Windows, and Office. So today my talk actually covers both of these aspects. Before diving into the talk, let's just go through the regular non-disclosure clarification. So as some of you know, Tahoe is actually already announced, but the details associated with it are still under NDA. And what this means is that if you're a third party that are working with Tahoe, you're not free to disclose details about Tahoe to your customers. So let's have a look at the agenda. What I'd like to go through today is to start by giving you a quick history of our search integration efforts with the various products across the company, and then share with you an architecture overview of our key components, and take a quick peek at some of the key search features in SQL Server, Exchange, and Office. And after that, I'd like to spend the rest of the time on Tahoe Search. And in that segment, I'll start by giving you a quick overview of what is Tahoe, and walk you through the Tahoe portal, which is our primary gateway into the search features right out of the box. And then I'll do a feature drill down. So I'm about to show you a timeline of the search integration efforts, and I'll go through some of these slightly out of chronological sequence because it'll help me describe how we evolved our code base. Our search technology is based on a proven indexing and search engine, which we first shipped in 1996 in Index Server and then in 97. And today, that is an integral part of the Windows 2000 operating system, where it's known as indexing services. So now let's jump back to the year 1998, where the Site Server group took the raw core indexing and search engine and actually wrapped additional infrastructure and architecture around that to do two things. The first thing is to add some extensibility so that we can index additional content sources other than just the NT file servers, which is what Index Server does. So that infrastructure code became the precursor of the later technology known as Microsoft Search Service. And we needed to actually rework the site server infrastructure because the indexing and the search capabilities actually needed to reside on two separate machines at the time. And in order to provide that as a single search service to be integrated with other server applications, we had to collapse that into a single service. And this is exactly what we did with SQL Server later on that year in 1998. In fact, we did that very quickly as a result of our extensibility architecture, which I'll go into later on. And later this summer, we re-released a new version of Microsoft Search, which was not only integrated with SQL Server 2000, but also Exchange 2000. And in the coming months, what you will see is a new wave of the Microsoft Search technology coming out with Tahoe and the next release of Office. So we can summarize the search technology integration in sort of four waves. The first wave premiered with SQL Server 7.0, where we took the site server infrastructure and we reworked that so that indexing and search became one single process in one shared service living on one machine. We then spent a lot of time working closely with the SQL Server group to integrate this service right into their relational database technology. And because we had very little time, we were only able to offer sort of basic full-text search capability there. And what I mean basic is essentially the indexing of plain text data stored in the tables, character-based columns in the tables of a SQL Server database. And also, when the rows of a table changed, we were only able to catch up with the indexing during the next scheduled index build. So the next wave of the Microsoft Search technology occurred this summer with both Exchange and SQL Server 2000. And here we've done a tremendous set of improvements. We've improved the relevance ranking algorithms in our search engine so that the searches are much more accurate. We've added improvements in our indexing technology in the area of performance so that we could do multi-threaded indexing so that if you have a number of processors on your machine, we will definitely do a faster job there. We work closely with the Exchange and SQL Server groups to make sure that their queries that they send to us are optimized and we can return it very quickly. We also worked with them to make sure that they can index rich documents. What I mean by this is that you can index attachments in your email messages for Exchange, and now, for the first time, you can also index your Word and Excel documents that are stored in the image columns of the SQL Server table. And because both SQL Server and Exchange support active-active clustering, we had to behave really well in that environment also. So the third wave is really emerging with the Tahoe beta that's about to happen. And here we've added additional engine capabilities, which I'll go through with you later on in the Tahoe specific segments. And by integrating with the document management aspects of Tahoe, we've given you the capability to sort of intelligently organize your information and search through that. On top of that, because we aggregate search results across a number of content sources that we index, you can essentially put documents on a number of different locations in your company, a number of different stores, and we'll go out and find wherever it happens to reside. So customers can continue to keep their information where it makes the most sense for them. So the last wave is really going on in parallel right now with the next release of Office. And here, the key is that we wanted to replace the Office Find Fast. And so in order to be able to do that successfully, we had to provide very good background indexing. And on top of that, we have the additional feature where the Office search can actually make use of the full-text indexes that have been built on other servers, such as Tahoe or indexing services. And it can take the results back and merge it together and present it to the Office user on his desktop. So now let's take a look at the architecture. You have a content source. This could be Exchange, this could be SQL Server, it could be any arbitrary one where you have a bunch of documents that you like to have full text indexed. And we have the Microsoft Search Service with its indexing engine, its search engine, and the Gatherer component. And this is the infrastructure which I was telling you about that the site server team did, so that it could go out and look at other content sources, any arbitrary content source, figure out the list of documents that it needs to index, and be able to recover from errors halfway through so that we don't end up starting all the way back at the beginning. So how do we glue these two pieces together? We've defined two components here. The first one is called the protocol handler. And the protocol handler is sort of named a protocol handler for historical reasons, and it really should be named maybe a store handler. And its sole job is to be able to understand how to connect to the content source that needs indexing, and to be able to go through, enumerate the list of documents that needs to be indexed, and retrieve that data and pass it on to the indexing engine. So the interfaces between the protocol handler and the Microsoft Search Service is very well defined. In fact, we plan to publish that in the Tahoe SDK to allow customers to implement their own protocol handlers to the content source that's of interest to them. The second component is called an iFilter. And many of you probably know this already, but an iFilter's job is to be able to understand how to crack the format of a document. So if we take Word, for example, it is basically a binary file with a bunch of control characters and some text. The iFilter knows how to strip out those control characters and pump out a textual stream, which then passes to the indexing engine. And what the indexing engine does at that point in time is that it applies special processing to figure out which which are the words in that textual string. And for Western European languages, this essentially, you can use white spaces as a very good hint to figure out what that is. But for other languages, such as the Far East languages, it's a little bit more difficult to do. And I'll have a slide talking about how we handle word breaking our language support a little later. So how do we combine the flow of all these components together? If you have a content source that needs indexing, the Microsoft Search Service loads the right protocol handler for that content source. And, oh, sorry, let me back up a little bit. We put the protocol handler and the filter into a separate process by itself outside of the process space of the search service. And this is because both of these components can be third-party written. And as a result, they could crash, or in the cases of documents where you can have a corrupt format, and no matter how well your filter is written, it may not be able to anticipate all the corrupt formats and behave appropriately. So in this case, if you encounter such an abnormal termination scenario, the search service will just restart the filter daemon process and keep on going. So now let's go through and figure out how it flows together. So the search service loads the appropriate protocol handler, and which then goes out and connects to that content source. And it retrieves the set of documents that needs to be indexed. It then passes those documents onto the filters so that the appropriate textual streams are emitted and given to the indexing engine. The indexing engine applies the appropriate word-based processing to figure out the set of word list that needs to be written into a full text index and puts that on the disk. And at that point in time, the user query can be then issued against the search engine, which applies that query against the full text index and returns the results back. Another optional interface for the protocol handler is actually our notification interface. And we use this when the content source has the ability to detect change. So what happens is, let's suppose you have a document that you've just written to the file system. And because the file system has native notification capability, the protocol handler associated with that can actually then queue the notification to the Microsoft Search Service, which will then go out and index that document. As a result, we keep the index pretty up to date with the changes. So let's take a look at summarizing our extensibility architecture. What this means is our Microsoft Search Service can actually get to any store. We have worked with our SQL Server and Exchange customers to be able to index SQL Server and Exchange. And we've also written a protocol handler to support the indexing of notes databases. And if there's another content source that you're interested in doing, all you have to do is write one of these. And as I said before, we plan to document that in our Tahoe SDK so that any ISV can do so. So we also support any data format, or we have the extensibility to support that. I'll go into, in the next slide, the list of filter formats that we do support. However, if that doesn't satisfy your needs, we also publish the interface for the iFilters. In fact, it's available today in the platform SDK, and you can go out and write one right away. In terms of the query interface, the query syntax is essentially full text extensions that we've added on top of the regular SQL 92 syntax. So people are pretty much used to seeing the style of these queries. And you can issue these queries through XML, HTTP, or ADO. So let's go through the out-of-the-box file formats. We support Office documents, Word, PowerPoint, and Excel, and HTML and plain text. And you can download from the websites of Adobe and WordPerfect the PDF filters and the WordPerfect filters. And if you have a need of files to get at a file format that we don't have here, you're free to implement your own using the iFilter interface in the Platform SDK. So now let's go back to the architecture picture that I showed you before, where the indexing engine looks at the files, the textual stream that the iFilter emits. What it has to do is to do language processing. So when I say linguistic support here, I don't mean the translation of a product's strings in the UI or error messages into the various localized forms. We actually take a look at the set of characters that are emitted by the filters, figure out which one of these are words. And as I said before, in the Western European languages, you can use white spaces as a pretty much of a good hint of where your word boundaries are. However, this is not true for Far East languages, which are made more of ideograms, and the words are not white space separated, and we have to do a lot more processing here. So as a result, if you look at the end-to-end sequence of our indexing, we actually have to go through filtering, we have to go through word breaking, and then we have to write it to disk. So overall, the process is pretty resource intensive. And this is why customers, especially for those of SQL Server and Exchange, wonder why full-text indexing takes a while. And I'd like to ask for your help in explaining this process to them, because we do a lot of work here, and as a result, it does take some time to finish. The other type of linguistic support that we have is in the query path. When you submit a search term to our query engine, what we do there is also apply word breaking to figure out which ones are the words. And what we also do in the case when you supply what we call a free text or natural language style query, what we do here is we actually do inflectional generation of those terms. And this is essentially generating the various tenses of a verb, or the singular or plural forms of nouns. So an example is if I search for the word drive, I'll find the word driven, drove, driving, and if I search for the word foot, I'll find feet. So in the cases where we do not have the language that's listed here, we load our neutral word breaker, which is essentially a smart white space-based word breaker that uses the NLS Win2K APIs to figure out what the characters are. But what this means is that this word breaker doesn't do well in cases where you don't have white space breaking for your word boundaries. So what I'd like to do now is spend the next 3 slides going through the key search capabilities for SQL Server, Exchange, and Office. So let's start with change tracking. This is a feature which essentially translates to keeping up with the changes in your SQL Server tables. As you may remember, I said that we supported pretty basic full-text indexing in SQL Server 7.0. When you changed a row in the table, we can't keep up with that indexing until the next time the index build is scheduled. Well, with change tracking, the SQL Server Protocol Handler has implemented to that notification interface that I told you about in the architecture slide. And when a particular row in the table changed, it tells the Microsoft Search Service that, oh, I've got a new row now that you need to re-index. And as a result, we go and do that, and the full-text index can be kept pretty up to date. I won't say real time, but it's pretty close. So the other major piece of support that went in was the filtering of rich documents, structured documents, your Word and your Excel spreadsheets that can be stored in the image columns of your SQL Server table. In SQL Server 7.0, the language support was on a server basis. So what happened was that if you had a French column, but your server was set to English, we actually ended up loading the English word breaker to process your French words, which doesn't end up giving the user a very good query experience. For SQL Server 2000, they've added column level collation, which means that their users can specify what the language property is for a particular column. And as a result, the underlying protocol handler can then tell us, oh, here's the language for this column. And we will then load the right word breaker and do the right thing. The top end by rank feature is a great e-commerce feature. And what used to happen with SQL Server 7.0 was that you would have an e-commerce company writing an application on top of SQL Server where their customers entered a pretty generic word and ended up with thousands of matches and wasting valuable CPU time. And so the application developers wanted a way to be able to restrict the set of rows that came back. And so what the top n by rank feature does is that it does allow you to restrict the rows to n, where n is 25 or 30 or whatever makes sense. However, we order it by rank for you so that you still get the most relevant results back in your first 25 set of rows. They've modified their English query capability in SQL Server to take advantage of full text search. And there was a tremendous amount of performance enhancements that went in. The most major one is related to the change tracking feature. In fact, if you used to use incremental index building, we really advise you to just switch over and use change tracking completely because it is just so much faster. So for SQL Server 7.0, we knew that the customers wanted to have active cluster support. But we really, at the time, run out of runway space to provide this capability in time for the RTM. And we've now spent, over the last year, a lot of time to make sure that the Microsoft Search Service interacts well with SQL Server in a cluster, active cluster scenario. And because the SQL Server full text feature was so well received in 7.0, the SQL Server folks have actually made this a typical installation feature. It used to be that you could only pick it when you do custom install in 7.0. So let's have a look at Exchange full text indexing. In Exchange 5.5, when you do searches, essentially what happens is that the search would go through character by character until you found a match. This is pretty slow. By hooking the Microsoft Search Service into it, all of a sudden you not only get fast searches, but you can find the attachments in your mail messages, which was what the old search couldn't give you. And the good thing about this is that you don't have to update your client interface. You can just use your regular Outlook client, and as long as the content indexing capability in Exchange 2000 is turned on, you can just do a find. And you'll get back your results just like that. So the other two interfaces where you can access full text search capability in Exchange 2000 is through HTTP DAB and OADB. These are programmatic interfaces where you can write your own application to serve your business needs. And in the case of Exchange 2000, they only supported full text, full and incremental indexing. We didn't have time to put notification support to get it working in before our RTM. So this is something that we'll be working on in a follow-on release. And again, because server clustering was so important, we do work well in conjunction with Exchange Server. So now let's take a look at Office 10. This is a Find Fast replacement. I'm sure many of you have actually tried Find Fast and felt how much it ground your CPU disk. Well, we are changing that. Office 10 Search is targeted at indexing documents on your local hard drive. And you can access this capability whether you're running Office on NT4, Windows 2000, or even the Windows 98 and Millennium platform. We actually took quite a bit of time, ported our search code base onto the Windows 9X platform, because originally it was server code base and it worked only on the NT platform. So we also can take advantage of the full text indexes that are built on other machines. So if you have a remote Tahoe server, for example, or you have index services running on an NT file server at a remote machine, you can access the information stored in those full text indexes through Office 10. We also reroute queries to what you probably now know as OSE, and the new name is really Office Web Server, OWS. In addition, we can route queries to Outlook as well. So what this means is that if your Outlook is connected to PSTs, you can search through that. It's not the fast full-text search engine inside Outlook, but if Outlook happens to be connected to Exchange 2000 and that has full-text indexing turned on, then you'll get fast searches through there. We spend a lot of time optimizing for client scenarios here. We wanted to have a very small in-memory footprint. And what we wanted to do was to make sure we don't intrude upon the user when they're doing their work. So as soon as you move your mouse or the CPU starts churning, then we back off right away. So for those of you who have actually tried Office 10 Beta 1 search, we didn't do as a good job there in backing off. And since that time, we've invested a lot of time to make things better. So we invite you to try that in Beta 2 and let us know what you think about that. We've listened to a number of Beta 1 customers giving us the feedback that, well, you really shouldn't have indexing turned on. So in Beta 2, you'll see this feature installing on demand. The one key thing to keep in mind here is that if you're installing on demand and you're about to search, you're probably not going to find anything because the index takes time to build. So if you really want to have search and do work with your Office documents, then what I would suggest is that you do pre-install the Office search capability. Give it time to index the documents on your machine, and then the next time you do work, you will find your search results. The Office search component shares exactly the same technology as what I've shown you with Tahoe. However, we are careful there to make sure that we don't contribute to the DLL hell scenario that's very common in the component world. So we've actually isolated a set of binaries that Office Search plops on your machine so that if you install Office 10 Search on top of a machine with Tahoe or SQL Server, for example, they don't know about each other and they will not interact in a bad way. And the last thing is that there's Search UI that's integrated right into the new Office application so that from your Word authoring or from your Excel spreadsheet, you can invoke Search, find the information you need, and plug it right into your document. So now I'm going to spend the rest of the time on Tahoe. And before going through the Tahoe search features, I want to give you a quick Tahoe overview. So how many people in the audience have actually gone to the Tahoe overview talks? Okay. And how many have gone to the additional Tahoe talks that Drew DeBruni and Jeremy Masner have done today? Great. So this should just be a quick refresher. When we first started building Tahoe, we went and talked to a bunch of our customers about their problems of managing information around their company. And what they told us was that they had a huge bunch of documents located everywhere on file servers, maybe in some other stores that they had bought, and it was just disorganized. They couldn't find information. In fact, some of them are sure that they had a problem for which a document has already been written about, and they just don't know where it is. So it's very frustrating. And some of these customers had actually started to look into building a solution themselves. Except in the process, they found they had to figure out how to hook up the web server with a file server, and maybe a database, and also source control. And it was just too complicated. So this is why we're here. We've developed Tahoe to be sort of a very simple bottoms-up solution which marries the document management capabilities with searching so that you can together, combined, have a rich collaborative platform. So now what I'm about to do is to show you a quick look at our Tahoe demo, which is our out-of-the-box web application for both searching and document collaboration. In terms of document collaboration, Jeremy Masner has already given a previous talk on this, so I'm not going to go go there. But if you're interested in and you haven't seen his presentation, you can go to it tomorrow. I believe it's around 2 o'clock in the afternoon. In fact, all the 3 talks will be repeated tomorrow again. So let me switch over and bring up the Tahoe portal here, this one. And what this is this is a portal which is written to the Microsoft Digital Dashboard Framework. And what we have here is the scenario for the demo is that there's a company called AdventureWorks which sells outdoor clothing and equipment. And we've populated some internal company documents into our Tahoe workspace so that I, as the AdventureWorks employee, can then go out and look for information that I need to do my job. So the scenario is, I'm the employee who has just heard that we have this new wonderful material called thermophil that is great for being the material for overcoats. So I want to read up about it. So I'm going to go to my portal and type in my search. Oops. And issue the query. And when I issue a query here, what lies underneath is actually a free text or natural language style query where we do the query expansion that I was telling you about into inflectional terms of verbs or nouns. And what you see here in the Tahoe portal is that we give you the matching categories that matched thermophil. And also, we have a best bets group, which essentially is the set of documents that some people have nominated to just be the top documents in the company, that when you look for the word thermophil, you should just be reading this document because that has the most amount of information that an initial reader starting off or maybe just having a good summary of the overall situation would want to read. So the rest of the search results is ranked in order of relevance. And I will scroll down and show you a particular format that we've supported. And that is the TIFF format, which is the new format for faxes. And what happens here is that we actually do optical character recognition here as part of the indexing and filtering process. So as you go through, you can see the word thermophil sitting right there. So the next thing that I want to do is I notice that as I'm crawling through the categories, that there is such a thing as a materials category. And what categories does is that it allows discoverability. So by looking at the search results, I know that there's a materials category, and maybe it tells me about other materials aside from thermophil that I want to find out about. So let's go to the Categories tab and look for materials. And I see other things here. Oh, Boraline and Rain-Tex and supple platinum. So categories gives you the ability for readers who don't know about specific things, that information that are lying in your document management collection, to actually browse through and very easily find that information. So I scroll down here and I notice that, gee, the author is Sherry Hart. I wonder what other documents she's written that I may be interested in reading up about. So I go to the advanced search web part that we've implemented. I want to search by author, search by properties here. And so I fill in this, and I enter Sherry Hart. And I get back a set of results, which she alone is the author. So as a result, we allow you to focus your search or browse and discover information. So let me go back to the slide material. So the benefits of Tahoe search are the following, and I'll go through and drill down on each one of the areas individually. We provide an accurate set of search results. In fact, we've invested in state-of-the-art technology with this search engine, and I have a slide that talks about that. By integrating with the document management metadata and schema capabilities of Tahoe, we allow you to target your search more specifically rather than across the whole gamut of properties. So, for example, when I just went through the advanced search option, I looked for the author that was Sherry Hart. And once you've found the results that you're looking for, you can subscribe to the changes in the results to keep up to date. We have a subscription engine which gives you that capability, and I'll talk about that later as well. We support a rich set of content sources and a number of alternatives to keep you up to date in terms of indexing. And our searches are secure. What this means is that if you're not allowed to see the document, then your search results won't even have it. Our content, our indexing and search capability is easy to use and manage. We provide you tools in that area. And finally, we do believe our search is scalable. You can use our search in your intranet portal scenario, and we support our ability to propagate catalogs to various search servers to spread out the load of indexing, and I'll talk about that as well. So how do we improve search accuracy? We actually did this using two approaches. One is to improve the algorithms in our search engine. The other is to give you mechanisms where you can inject some knowledge about the documents and about the information in the corporation. And so together, the two combine to give you really rich search results. We have, working in Microsoft Research, a leading expert in information retrieval. And over the last couple of years, we've worked with him to do technology transfer of a new probabilistic ranking algorithm that now greatly enhances our search results. And what this algorithm does is that it makes statistical calculations of the frequencies of words inside the document as well as throughout the set of documents that you're indexing. It also takes into account the length of the document in the calculation. And as a result, you end up having a good normalized understanding of how important that word is throughout your document corpus. We have a feature called attribute weighting, which you can tell us the set of properties that are more important to you in your corpus. And what this means is that if you're looking for the word internet and it's a hit in the title or subject of a document, then that's more important than if it's just a single occurrence in some random document. And you can tell us that through specifying how that attribute weighs in the query, and then we can return the ranking of that document appropriately. In Tahoe, we provide a customizable thesaurus for you to plug in the synonyms that you use in your corporate taxonomy. So in the Microsoft case, people who want to search for IE will end up being able to find the documents with the string Internet Explorer without IE in that document at all. A number of our Western European customers, particularly those in France and Germany, have over the years asked us to support accent in sensitive search. And we finally accomplished this in Tahoe. And what this means is that when you search for a word such as ole, spelled O-L-E with the accent, all you need to do is type in O-L-E without the accent. We'll find you matches in both. We've managed to rewrite our English, French, and Spanish word breakers. And this resolves a lot of issues that people have encountered with our previous versions of our search technology. And it's also significantly faster, which certainly helps us with our indexing performance. For HTML documents, there are often cases where there's no language tag. And in those cases, we actually go in and try to automatically detect the language and suggest the word breaker to use. So metadata adds meaning. This is the case when I was telling you about where you're allowed to, we help you inject some knowledge about your documents into our system so that we can give you better search results back. So as you've seen in the portal, somebody has hand-tailored a document with the best bet property and promoted that up to the top of the search. And this is where readers will see it immediately. In the cases, there are other cases when we actually help you out as well. By making use of the attribute weighting capability, our portal has just implemented a feature which automatically nominate some of the higher ranking documents into the best bet section. And when you folks load up Beta 2, you will see this capability, and we really would love to hear some feedback about how well this behaves. We've had a mixture of feedback internally within our organization that says, well, you should only just do hand tagging of the best bets instead of automatically nominating. And then there's a bunch of other people in the other camp which says do both. So we'd love to hear what your thoughts are. By indexing the metadata, which are the properties in the document profiles in Tahoe, you can focus your search in much more precisely rather than just issuing a search term against everything and then getting everything back. So by restricting your search, it's not only more efficient, you can focus it and get the right results. So for notes, one of the content sources that we support is notes databases. And as you probably know, they have their own notes columns and data types. We allow you to map the notes columns to the fields in our document profile so that you can focus your search also there. So categories are essentially a knowledge hierarchy that allows you to go from broad topics down to very specific areas. And if you organize your content by topic, what you're doing is you're really boosting the discoverability of information for your readers. And what it is also doing is that it allows you to separate and release you from being bound to the storage hierarchy of your documents, so that your authors may want all their specs to be under a single directory organized by their names, but your readers can't find anything in that organization and would rather have a hierarchy that goes through maybe products, product areas, and sub-areas. Once you've manually categorized a bunch of documents, you can actually make use of our auto-categorization or category assistant feature to automatically categorize the rest of your documents. And what we have here is underneath another use of Microsoft Research technology called support vector machines, where we go out and look at the set of documents that you've already manually categorized. And we use that as a training set so we can figure out how the documents are similar within a category and how those documents are different from those in other categories. And so in order to be able to do this really well and get back good results from auto-categorization, you should be having at least about 10 to 15 documents and about 5 categories so that you can get better results. So once you've found the right search results, you can subscribe to them and be kept up to date. We have integrated a persistent query service engine into our Gatherer component. If you remember from the architecture slide, that's sort of in the indexing pipeline of our processing. And what happens there is that as a document comes in, we index that and match it against the subscription that you said was interesting to you. and then optionally send you email notification or just notify you through the portal. And you can subscribe to changes to a single document, to a set of documents, to folders where new items are coming in or being deleted, a set of search results based on a query term that you submitted, or categories. We support a rich set of content sources. You can index other Tahoe servers, web servers, file servers, Exchange 5.5 and 2000 public folders, and also notes on databases. If you see a content source that's not listed here that you need, you can take the protocol handler interface that we're going to publish in the Tahoe SDK and implement the protocol handler yourself and plug that into our search service, and we'll go out and index those documents for you. Our searches are secure. So what this means is that if you're not allowed to see a document through the native access, then you just won't see that document in the search results at all. We have direct support for Windows File System, Exchange, and Tahoe. And our search security mechanisms, it's NT-ACL based. So what this means is that when you're implementing a protocol handler against a content source that has its own proprietary security system, as in the case of Lotus Notes, you have to provide the mapping from that security system to our NT-ACL. So for Lotus Notes, what we did is that if you want to set up security for notes crawls, you have to provide an NSF file with 2 columns in it. The first column being your notes user ID, and the second column being your NT user ID. And we then do the right thing. If you're using NT groups to implement your security, there's one thing to be aware of, and that is we need the groups to be domain-based. If you have local groups, we can't go out and resolve that security against a remote server. So we default to not accessing that document just to be safe. Now that you have a variety of content sources and secure search capability, you want to be able to keep your indexes up to date, and we provide you a number of ways to do this. You can do a full build of all your indexes, and this is usually done right away when you've configured your content source to be indexed. The other thing you can do after it's been built is that you can set up incremental build schedules to keep up to date. And here we actually offer an additional capability to be smart about that incremental processing. And I'll go through that in the next slide. If your content source has ability to detect change, such as NT file servers, and our local Tahoe server has that capability as well, then we go through the notification interface that I talked to you about and to plug in and let us know when something has changed, and we then go out and index your document. So let's have a look at the adaptive indexing capability. We use a statistical algorithm to figure out the rate of change for your document, and we use that to project when the document would next change. So let me give you an example. Let's suppose I've set up my content source to be incrementally indexed once a day, and I've got a portion of a website here where the documents change once a week because that's the way that they upload changes. What happens is that we learn this rate of change. And so at the end of the day, when we really plan to go out and index, to look at those documents and see if it's changed so that we can re-index them, we know that this set of documents just don't change that often. So we don't even go out to the network. And we save the network traffic, and by the end of the week, we then go out and retrieve that document for indexing. And when we retrieve that, we actually check to see if that document has changed to validate our guess. And so you may ask, well, what happens if your guess is wrong and miss a number of documents? Every 2 weeks, we go out and we actually look at everything to just validate our beliefs. So if that document all of a sudden now changes twice a week, we'll update our statistic algorithms underneath to relearn the change pattern. So in using this capability to do MSW, or internet crawling, we've noticed that we had a 6-time decrease in the amount of time that we need to do our full text indexing. We also offer capabilities to allow you to have fine-grained indexing control to reduce the network traffic that you may incur, because some websites just don't want to be hit that often as you're crawling. They're really, really busy, and so they only want to be hit a certain number of times. We offer you site timing and capabilities so that you can only go out there once or twice a day, or whatever the number of times that you need. We respect the robot protocol interface, where some websites just don't want to be hit at all, and we just don't bother indexing that. So our indexing and search capability is very easy to configure. For content source management, we offer you a wizard, which essentially steps you through how to set that up. And you can invoke this from web folders from the Windows Explorer. We don't need you to be an NT admin to configure the content source. And what this means is that you can bring that job closer to the group that actually needs to figure out which information you want to index. The server is managed by a Tahoe MMC snap-in. And we've also introduced, new to Tahoe, is something that we call a gather log viewer, which helps you to do problem determination when you hit index build issues. So let me switch over and do a demo for you. So what I have here open on the screen is the web folder to the Tahoe workspace. And the content source management is located in the management folder in the content sources subfolder. So here we have the add content source icon, which if you double click turns into a wizard that will help you configure a number of your content source crawls. So let's go through and let's actually configure a notes database crawl. So what I have here is a notes server called Tahoe Demo 2 that's already set up and running. And I'm going to pick the British Rail database, which contains a bunch of schedules, train schedules. And I want to use the British Rail schedule document profile to do my mapping between the notes columns and my local set of properties, which I'll then use to query. So what this does is that it brings up a set of properties in my local document profile, and I'll then do mapping to the notes columns. So these are the columns in my notes database, and I actually want to do mapping. So I'm going to go through and actually map all of these. So title gets mapped to title, and then arrival time gets mapped to arriving, and departure time gets mapped to departing, destination gets mapped to, origin gets mapped to from, and let's map author to owner, and let's map contents to comments. So let's then proceed and give a name to this content source called British Rail Schedule. And at this point in time, I'm not going to start building in an index right away, because I noticed that I already have it added, and I didn't delete it yesterday when I was setting up my demo. So let's go to this one right away. And what I'm going to do here is this was a demo that I set up yesterday. And what I did there was I stopped the Note server and started a build. And when you stop the Note server, of course, the index build will fail. And so when you click on the content source for that British Railway icon, what you see here on the left-hand side of the pane is that there's a message saying, update failed. Click here for details. So when I do that, we have the gather log viewer which shows up. And when I look at the detail log entries, it says there's an error fetching a URL. And when I click on that, it says an error has occurred on the server. Make sure it's functional. So what this says is that, gee, maybe I forgot to start my server and I should go up and do that. And since in this case, my server was already started, let me go back and just start the full text indexing. So in this case, you will see that this is a nice green healthy bar. We've done everything. We've indexed 17 items. We failed to index 0 items, and nothing bad happened. So the gather log viewer allows you to do the problem determination that you need. So let me show you the setting up of another index. Let's pick a website. Let's go to www.kmworld.com and call that KM World. And let's start building the index right away. So we refresh, and we click on that, and we see that it currently contains 22 items and is not finished building. So again, we provide you all the information right on the left-hand side of the pane for easy diagnosis of what the current situation is. So now let me just switch back to the rest of the talk. Yes, because that was one of the hard cuts that we had to make for our beta 2. We had a number of issues that we needed to resolve, and we wanted to ship our product. So we cut the SQL Server OLEDB content source. And the reason that we rationalized that cut was because we were exposing the protocol handler interface, and because OLEDB is a standard way to access SQL Server, we figured that people out there can fairly easily implement one of their own. So out of all of these, that was the one that we've chosen not to support this time around. But in the future, you'll certainly see us adding that support back in.
By RTM?
No. Future as in post RTM. So now that you have all the rich content indexing features and rich support search results, we allow you to scale through your intranet. And how you do this is that if you have a large amount of information to full text index, we allow you to spread that indexing capability across a number of dedicated index builders. So what I've shown you here is a topology where we have 3 machines that we want to go at. The web files and files on file shares, Microsoft Exchange 5.5 or Microsoft 2000 public folders, other Tahoe servers, or Notes databases. And we go out and crawl that with our dedicated index build machines. And as they are finished crawling, we propagate that dedicated workspace index into our search server and make it available for user queries. So to summarize, what we do is for your basic departmental scenario where all your indexing is a bunch of local documents or a small number of documents here and there, you can combine your indexing and search feature on the same machine. In a larger company scenario where you want to spread that across a bunch of servers, you can have your dedicated index build machines. And once they're done, you can propagate the index to a single portal search server. And what happens at the portal search server is that your categories and your document profiles are managed there. However, your subscriptions are actually managed at the index build machine. This is because if you remember when I talked about subscriptions, we actually look at the documents that they're coming in and we match the queries that's interesting. So that's why we do it at the index build machine. So the flip side of indexing scalability is scalable distributed search. What happens is that you may be in a scenario where you're in a widely geographically distributed company, and you don't want your customers to go through slow wide area networks to get at a single search server. Or if you have such a large number of users who are querying a single machine, you may want to load balance some of that across a number of search servers. And what we allow you to do is to duplicate your search server exactly. And by exactly, I mean it's a complete replacement of all the content and the index, including subscriptions on the target machine. And then you can issue queries against those individual search servers. So that concludes the Tahoe search portion of my talk. And I want to spend a minute with you going through our future search vision. You'll see us in the future scaling up to index an ever-increasing number of documents in your corpus. And this is really driven out of the needs of SQL Server and Exchange, especially in the case of SQL Server, where their desire is really to be able to support hundreds of millions of items or rows in their SQL Server table that can be full-text indexed. Today, our top end there is really around 20 to 30 million. And so in the next release, we're going to have to look seriously at how to extend that upper end number. You'll see us continually extending our search engine capabilities and integrate more deeply with the Microsoft applications. We want to be able to provide even more seamless manageability and a whole lot more performance, both in the indexing area as well as in the query area. We'll be working with ISVs to get protocol handlers to those interesting content sources that our customers are interested in accessing, but we really don't have necessarily the bandwidth to do. And similarly with iFilters, we want to be able to get at those document filters that some of our document formats that our customers are interested in, but we probably won't be coming out with the gamut of 100 file formats, and we rely on our ISV partners to be able to provide that for us. So overall, we're working towards a goal where we help people find information more easily. And you'll see us drive the use of our common search technology more and more across the Microsoft applications. By continually enhancing the search engine features and scalability, you'll see us becoming the showcase. Sort of from a scalability perspective, you'll see essentially the server applications being the showcase for that capability. And for Tahoe, we really want to make Tahoe the best place to organize, share, and find information. Now, before I go and talk about the next slide, which is essentially the call to actions, I was wondering how many people in the audience are interested in the co-residence capabilities or issues of putting SQL Server search and Exchange search on the same box and maybe even Tahoe on the same box. Does anybody want me to go into that a little bit? Okay, so this is a single shared service. And what this means is that each time you put a newer product with a higher version number of search on that machine, we will actually go and upgrade the bits. And what this means is that you do get while you do get the additional capabilities of the engine, there are some things you've got to be aware of. So for example, in the case of Tahoe, in order to be able to provide some of the rich engine capabilities that we're coming out with, we've had to change our catalog underneath full text catalog format. So when you install Tahoe on top of your Exchange or SQL Server machines, we go and automatically upgrade the full text index format for you. And because indexing can take a while, we know that this is a pretty time-consuming process. So we advise our customers to do this at a time when the server is not going to be busy. And on top of that, because there are additional search engine enhancements, there are some behavioral changes in the way queries are handled. As I said before, in Tahoe, we offer you the capability to do accent-insensitive search. So when you put Tahoe on a machine with SQL Server, where you couldn't, when you actually did a search for the word Olay, you only found the exact match for that word. With Tahoe on the box, your SQL Server application all of a sudden starts returning you more information. It's a good thing, but it's something to be aware of. Now, for Beta 2, we put in a mechanism where we wanted the user to make sure that they're very conscious about putting these two together. So if you just installed vanilla Tahoe and attempted to put it on a box that has SQL Server or Exchange, we will pop up a piece of UI and setup that says, sorry, you're not allowed to do this because we're a beta that's under evaluation. However, if you really want to see how these products interact together, go read the README. And the README has this little piece of instruction which says, if you twiddle this bit in the register that says, I really, really want to put these bits on my machine, then we'll go out and actually do that. So you can shoot yourself in the foot if you want to, but we actually make it hard for you to do that. So the other thing to think about when you have these applications on the same machine is that Exchange is a mail server, and it's a heavy sort of interactive user scenario. And so typically, full text indexing resides in the background, and the resource usage for full text search is sort of set way low. And in fact, I suggest for those of you who are interested in the feature for Exchange to go and read the deployment guide. It has a lot of information. SQL Server, on the other hand, their users typically want to crank the resource usage way up so that you index as fast as you can to provide the results. And when you put these two together, they sometimes don't match. So be careful when you put these two products together. You may not want to if you want to use search capabilities for those products. And in terms of Tahoe, we're setting the resource usage to be in the middle so that you can sort of do both indexing search at the same time. So now let's take a look at what's happening right now. On Monday, we're building our escrow build, and it'll be available at that file share. And I ask everybody to go and download it and try it out. And give us the feedback. Tell us what we did right, what we did wrong. Because even if we can't incorporate your feedback this time around, we sure love to have the long list of features that we can work on for the next release. Review our documentation. Tell us what information is missing there that really you need to help you do your job. And nominate customers for our rapid deployment program. We need some partners who can give us the type of feedback so that we can figure out in between now and RTM all the deployment issues that we still need to conquer. Join these discussion aliases and the news group to share information and to ask the questions that you need. And there's also a bunch of PowerPoints available at the website over there that you can get for further reference. So that's essentially the end of my talk, and I'd like to open it up for questioning. If you guys can go to the speaker.